Alright, so today we're going to talk about integrated circuit technology, right, or IC technology for short. And the area we're going to look at is logic levels, right? So today we're going to go into logic levels. I'm going to show you all about compatibility. But before I do that, I have to introduce you all to different technologies. We're going to be looking at CMOS, 5 volts, CMOS 3.3 volts. We're going to look at TTL, and we're going to now put them together and see if it's possible for them to have compatibility issues, right? And which ones we should drive with the other, right? So let's get to it. So there are 4 different logic levels, and I'm going to present them to you over here in sequence. The first is VIL, which is voltage input low. Now VIL is more or less the range of voltages when placed. If any voltage within that range is placed on the input of the technology, it would be interpreted by technology as a logic 0. Now VIH, any voltage within that range VIH once placed on the input of the pin for that technology, the input of that technology would be interpreted by that technology as a logic 1. Now let's look at the output parameters, VOL. And you have to keep in mind that the technology now has to, whichever IC we use, whatever technology we are building it with, it has to specify its outputs, which could take the values 0 or 1. It has to specify its outputs on the output pins. So if that technology, if that IC wants to specify a logic 0, it will have to specify in the form of a voltage within the range of VOL. And VOL is the voltage output low. So it means that the output, once it has to be logic 0, must take any value within that range VOL. Similarly, for VOH, which is voltage output high, if you have a particular IC, the output pin has to be to specify a logic 1, then the voltage on that output pin must take any value within the range VOH. Now before we move on, there are 2 terms that I want to actually bring to your attention. 2 acronyms, TTL, right, and CMOS, right? So I'll begin with CMOS. CMOS technology, which we will speak about just now. That acronym CMOS stands for complementary metal oxide semiconductor. And TTL, that basically stands for transistor logic. It's built on bipolar junction transistors. So let's move forward. So let's begin with plus 5 volts CMOS technology. We're going to look at both the input and the output side, and we're going to learn a lot. So let's get to it. Okay, so this diagram gives us the input and output logic levels for plus 5 volts CMOS technology. Now, we see the 4 logic levels we spoke about previously: VIH, VIL, VOH, and VOL. So let's first look at the input side. We have, for this input side, we have a range of voltages which will be interpreted by the technology as a logic 1 or a high. We also have a range of voltages which would be seen as a logic 0 or a low. And we also have an unallowed range. Now keep in mind we have VIL max, which is the maximum value to which a logic 0 would be interpreted as, right? That is the maximum voltage basically that would be channeled towards this technology that it would interpret as a logic 0. And we have VIH min, which is the minimum voltage that should be inserted to this technology, which will result in that technology interpreting that value as a logic 1. So for plus 5 volt CMOS technology, the range of voltages that are going to be interpreted as a logic 1 are between the range 3.5 volts and 5 volts. So you more or less have a 1.5 volts range on the upside, which would be interpreted as logic 1s. On the logic low side, the range would be 0 volts to 1.5 volts. Any voltage within that range would be interpreted by the technology as a logic 0. On the output side, there's a range of voltages that would be seen on the output of that technology if it's specifying a logic 1, and that is 4.4 volts to 5 volts. VOH min is the minimum voltage that would be outputted as a logic 1. On the logic low side, 0 to 0.33 volts is the range of voltages that when this technology outputs a logic 0, it would be seen, it would basically be meaning it's a logic 0. Right? So when that technology outputs 0 to 3.3, anything within that 0 to 0.33 volts range, it is basically specifying a logic 0 on the output ports. What about plus 3.3 volts CMOS technology? Let's look at that. Now this is the input and output logic levels for plus 3.3 volts CMOS technology. And like the plus 5 volts CMOS technology, more or less the same thing applies, just the difference is that we limited to plus 3.3 volts. So in the case of plus 3.3 volts CMOS technology, VIH ranges 2 volts to 3.3 volts on the input side. The input low is 0 volts to 0.8 volts. Right? On the output side, VOH is 2.4 to 3.3 volts. And VOL is 0 to 0.4 volts. Finally, let's look at TTL technology, input and output side. Let's do it. In the case of TTL technology, and in case of TTL, it's plus 5 volts. So, VIH has a wider range than plus 5 volts CMOS technology. So the range is 2 volts to 5 volts. So it means that any voltage, if I apply any voltage within that level, that range to TTL technology, it would be seen as a logic 1. On the low side, 0 to 0.8 volts is going to be interpreted as a logic 0. The unallowed range, of course, is much smaller than plus 5 volt CMOS technology. On the output side, it's a larger range, 2.4 to 5 volts. If this technology needs to specify a logic 1, it needs to specify a voltage within this range, 2.4 to 5 volts. And if it needs to specify a logic 0, it would be between 0 to 0.4 volts. So before we go, it's important for us to look at now compatibility, right? And it's very important to look at the topic of compatibility. If we're interfacing CMOS technology to TTL technology or vice versa, we need to know whether they are compatible and whether we could actually drive TTL with CMOS or if we could drive CMOS with TTL, right? And that's very important. So let's do some work on that. So in this segment, we want to determine whether we can drive TTL with CMOS or vice versa. So we want to know whether we can connect the output of TTL, of a IC built on TTL technology, to the input of an IC built on CMOS technology and vice versa. So you want to know if these technologies are compatible. And to know this, we have to look at the output voltage level profiles for TTL technology, right? The output level profile for TTL technology, and put it against the input voltage level profile for CMOS technology. And we now have to look at the logic levels for both of those profiles. So in the case of TTL, we know that an output is going to fall within the range of 2.7 to 5 volts. Our output high, a logic 1, is going to be mapped to a voltage between the level of 2.7 volts to 5 volts. And we know for CMOS technology, an input between the range of 3.5 volts and 5 volts is going to be interpreted as a logic 1. So if we put these against the other, it means that there's a portion of voltages coming out of a TTL IC that is not going to be interpreted by the CMOS technology as a logic 1. This range here between 2.7 and this range 3.5, those values are not going to be interpreted by the CMOS technology as a logic 1. So on that alone, we could say that they are incompatible. You want to ensure that all the voltage, the values between 2.7 and 5 volts from the TTL technology would be properly interpreted by the CMOS technology as a logic 1. And that cannot happen, because the CMOS technology will only interpret voltages coming in between 3.5 and 5 volts as a logic 1. Let's look at the logic low side. A logic low and out of TTL technology will fall within the range 0 to 0.5 volts. So that will easily be interpreted by the CMOS technology as logic zeros, because for the CMOS technology, anything within the range 0 to 1.5 volts on the input side will be interpreted as a logic 0. But because of the logic high situation, they are incompatible in that format. So therefore, we cannot drive TTL, we cannot drive CMOS technology using TTL. Hence, we cannot connect an output of a TTL to the input of a CMOS technology and expect the circuit to operate properly. Let's look on the other side. Could we drive TTL using CMOS technology? So we have to look at the output profile for CMOS technology, 5 plus 5 volt CMOS, and the input profile for TTL. And now we have to look at it and we say, okay, a logic 1 will be corresponding to voltages within the range 4.9 to 5 volts. On the CMOS technology side. On the TTL side, it will interpret anything between 2 volts and 5 volts on the input side as a logic 1. So easily all of the values that are going to be outputted or specified as a logic 1 coming out of the CMOS technology would be interpreted by the TTL technology as a logic 1. And the same thing will happen on the logic 0 side. All of the values that can be possibly outputted from a CMOS technology, CMOS IC, the pin of a CMOS IC will be easily interpreted by a TTL IC on the input side as a logic 0. So in that form, basically, they are compatible and we can drive TTL using CMOS technology. Hence, we can connect the output of a CMOS chip to the input of a TTL.